Hello, everyone. My name is Gato. Thanks for tuning in. Today, we're here to talk about conversational artificial intelligence. Hopefully, you can appreciate this complex title on your screen, but what it's trying to convey in a nutshell is how do we teach machines to mimic human understanding? But before we dive into that, let me tell you a little bit more about myself and my company, TEKsystems Global Services. I'm Caro, and I was trained formally in brain and cognitive sciences. I studied at MIT, where I spent a good part of those years working in a lab dedicated to exploring the neural correlates of habit formation and ritual behaviors in the non-human primate model. That led me to be very curious about real-world applications, and I ended up starting my career in process design and process improvement. This eclectic combination led me to stumble into the world of conversational artificial intelligence, which we'll be referring to as conversational AI for the sake of brevity. My foray into conversational AI began in a large global financial services institution when they were doing their first implementation of a conversational interface, and they were looking for help with humanization. So essentially, this made me responsible for driving the conversational user experience of our conversational platform. I spent 2 years leading the charge there before coming over to TEKsystems Global Services, where I'm essentially still responsible for humanization, but now I'm doing so as a practice architect in our data analytics and insights practice. And I drive humanization strategy through our internal platform, Sage. At TEKsystems Global Services, we specialize in full-stack technology services. We're located across the globe in over 100 offices, serving over 6,000 clients, 80% of which comprise the Fortune 500. Our goal is to be our clients' partner in driving digital transformation. Our closed-loop conversational assistant, Sage, is our internal accelerator. Sage is aimed at helping get conversational AI journeys started for our clients. By leveraging existing UI channels, Sage adds the conversational and fulfillment layers that drive success. So now, let's get to our agenda. As I mentioned, today we're going to be talking about how to teach machines to mimic human understanding. So to do so, we need to talk about what is conversational AI and why does it matter in the first place. Then we'll talk about what conversation is, both from a human-to-human perspective as well as a human-to-machine perspective. Then finally, we'll talk about how to build a robust intent recognition framework and how to monitor it post-implementation. So what is conversational AI? If we take a step back and think about the field of AI in general, I think this quote from Sebastian Thrun, the co-founder of Udemy and former professor of computer science at both Stanford and Carnegie Mellon, in essence, what he's saying is that artificial intelligence is essentially a humanities discipline, because what we're trying to understand is human intelligence and human cognition. I think conversational AI is even more human at its core, because we're attempting to have machines engage us in the way human partners would engage us in conversation. So there are several technical approaches to conversational AI. The first that we're going to discuss is the most traditional approach, which is rule-based conversational systems. Essentially, these are systems that are trained on a predefined hierarchical set of data, which corresponds to predefined responses that will be outputted by the machine. The most famous example, or at least my favorite, is a bot from the 1960s that came out of MIT's that came out of MIT's computer lab. Her name was Eliza. Eliza was modeled after a famous psychotherapist known for parroting back to his patients what they would say to him. Eliza was so well received that, much to her creator's chagrin and insistence that she was not human, her users felt that she was more empathetic and more human than previous psychologists that they had interacted with. The next type of approach is called a retrieval-based approach. Retrieval-based systems are essentially where we are today. The bulk of systems in production are powered by retrieval-based conversational AIs. Essentially, if you can think of a time when you've interacted with a chatbot or a voice bot, they were likely a retrieval-based system. So what is the system? It's essentially a step above a rule-based system in that the machine uses heuristics and turns the problem of interpreting a user's utterance into a probability problem. So again, the machine can only respond with predefined responses based on the user's input and whatever is most likely to be the right response to that user's input. So rule-based systems and retrieval-based systems both have in common that they cannot generate any novel content to respond to users with. That's where generative systems come into play. So generative systems attempt to overcome the limitations of these two previous systems by providing novel responses or responses that haven't been predefined to the end user. So unlike the previous systems, which are trained step by step on the responses, generative systems need to be trained end to end on conversations so that they can generate novel responses. Ensemble systems are very much like the name would suggest. They take a combination of rule-based, retrieval-based, and generative approaches as per what the context dictates. So they are capable of using any of these depending on the need of the specific context. Grounded learning is based on the idea that human language is grounded in your perception and your sensory motor experiences. So our understanding of language is not just limited to words relative to words, but to the warmth of the sun on your skin when you understand the meaning of hot, or the freezing sensation in your hand when you pick up an ice cube. And that corresponds to your understanding of cold or freezing. So essentially, machines do not have these perception mechanisms that human beings do, which makes it very difficult for them to learn language in a grounded manner, the way that humans do. Finally, we have interactive learning approaches. These are based on the idea that human beings need to cooperate with each other to fulfill their needs. And when we cooperate, language evolves with that cooperation so that we can meet these needs. Interactive learning systems attempt to respond and generate novel responses through learning interactions. Now, grounded learning and interactive learning, despite many years of research, are still the least used approaches and the most common in academic or research settings. I say all this because the focus of our discussion today will be retrieval-based conversational AI. Once again, because the bulk of systems in production are powered by retrieval-based systems, and because my personal and professional experience is also rooted in the implementation of retrieval-based conversational systems. So at a high level, What's going on when we have a conversation with a retrieval-based system? There's a user utterance, which is the jargon in the industry for a user's input or what a user might say. There is a classification of said input, a recognition of the intent, and finally, there's a subsequent system response to the user's request. A lot of us are probably focusing on the technical challenges that come with this, but it's really important to remember that this is very much a design challenge as well. The conversational experience that a user walks away with greatly impacts their desire to re-engage with the system and their trust in the system, and therefore has a serious impact on your ROI of an implementation of such a system, because if your users can't get what they need in a satisfying way, they're unlikely to want to engage with your conversational platform. Now, the conversational experience is influenced by three large areas that are rooted in good design: conversation design, information architecture, which is essentially how the knowledge within the brain of your conversational interface is related to other knowledge, and finally, the subject of our discussion today, the intent recognition framework, or how well your conversational system is able to understand the query of your user. In a retrieval-based system, where you have a predefined response, the ability to correctly identify the user's input and provide an appropriate response has a significant impact on their experience. So, I've started to talk a little bit about why conversational AI matters, but let's really dive into that. If you want to know the short story, it's because conversational AI is everywhere. Think of your own lives. How many of us rely on Siri, Alexa, Cortana, Google Assistant, or other similar platforms to accomplish daily tasks? Let's take it a step further. How many of you can think of times where in your professional lives you've had to interact with a conversational assistant to accomplish tasks? Anywhere from the world of IT support to HR and onboarding and other things like that. Conversational experiences are becoming ubiquitous, not just in our personal, but in our professional lives. Let's talk about the consumer experience, aka our personal lives. There are a plethora of sources out there with a lot of statistics, a lot of information, a lot on trends. I've only posted a few of the ones here that stood out to me, but if you're reading all that's coming out in terms of conversational interfaces, you've probably heard how, from the consumer's perspective, they're basically everywhere in our lives. Companies are reporting 20% plus increases in consumers that are using conversational interfaces to interact with them. And they're also reporting that this is leading to a 20+% reduction in churn. What I find the most interesting is that consumers are reporting that they would speak to a conversational interface as they would a friend. I can certainly relate to that because my 5-year-old son is adamant that we call people only with Siri's help. But now I want to talk about the employee experience. I would like you to think of a time when, as an employee, you've had to interact with a conversational interface. Was it a good experience? Chances are it was not. I myself have had many experiences in this realm that were far from pleasant, and I am a woman on a mission to change that. So today, we will be focusing our intent recognition framework within the context of employee experience use cases because these are more transactional in nature and the rules of engagement in transactional exchanges are different than in more social or open-ended exchanges. So we're really going to focus on how the intent recognition framework can be leveraged to make amazing experiences for the employee. Before we move on, you'll see that in our own success story at TEKsystems Global Services, we were able to automate 30% of IT support requests through one of our implementations of a conversational interface. And PwC is predicting a 26% transformation of GDP of the global economy by 2030. That's a huge opportunity because this is subject to change due to the types of productivity increases that these conversational interfaces are set to bring into our lives. And by as soon as 2021, it's predicted that 25% of digital workers will be relying on conversational interfaces or work experiences. Now comes the fun part. Let's talk about conversation itself and what human-to-human conversation entails. The four areas that you're seeing on your screen, Broca's area, Wernicke's area, the insular cortex, and the angular gyrus, are known to work together as a network to help us process and express language. These four areas, apart from other brain areas not pictured, all have to work together to help us process words, their meaning, and formulate comprehensible responses. And that's just words. If we extract one level further, there are also many physiological as well as visual cues involved in conversation. There are actually many books with a title such as The Art of Conversation, because when we think of all of these feedback mechanisms and all of the brain regions involved in conversation, it really is an art form. Human conversation is very complex, but why do we take it for granted? Well, that's probably because as humans, we've been talking to each other for over 100,000 years. We've had lots of time to have our brains evolve and adapt to this type of communication. So that's why it feels natural. Now, I think this quote is very important to think about because it's being argued that the basis of any frictionless interaction are the ability to understand unambiguously and the ability to answer accordingly. That sounds like common sense, but think about how many experiences you've had that have left you wanting to bang your head against the wall because of simple miscommunications. Human chatbot communication makes no exception to that. It is our job as those of us working in this field to ensure that our users walk away feeling great and feeling empowered and feeling like they were heard and got everything they need from a conversational exchange. Now, why if human conversation feels so natural, does human-machine conversation not feel anywhere near as natural? Well, if you think about it, we've only been talking to machines for about 40 years or so, because yes, I'm counting Microsoft DOS as a conversational interface. Do with that what you will. But in any case, 40 years versus 100,000, that's a big gap. So it's our job to make sure that we do everything possible to overcome these gaps. How do we do that? Well, your first utterance from your user or that first input that they say, how you respond to that, That's going to be crucial in setting the tone for the rest of that conversation and for how the user walks away feeling, and therefore will impact the adoption of your conversational interface. These are just some silly examples of frustrating exchanges where the user has said something fairly basic, but that first utterance was not responded to adequately and could set the tone for potentially a terrible exchange as it goes on. I myself have had some experiences like these and have had emotional reactions ranging from anywhere to laughing hysterically to wanting to run out the door. I'm sure we can all relate, and I am passionate about driving good experiences and making sure that this doesn't happen to users. I certainly don't want you to feel this way when you're interacting with any conversational interface. So let's talk about how to make sure that our users have great experiences. Because as we can see from the infographic on the screen, there are some common themes when it comes to the issues that people face when interacting with conversational interfaces in the workplace. The most common, which are misunderstanding requests and misunderstanding the nuances of human dialogue, are due to the intent recognition framework. And I argue that the execution of inaccurate commands, which is the next most common issue, is also due to the intent recognition framework, because if you've misunderstood a request and you act on it before you get any confirmation or any chance to remedy it, of course you're going to be executing an inaccurate command. So we'll be talking about the intent recognition framework and how to make sure that these errors don't happen in your conversational interface implementation. So first, we'll talk about a one-to-one framework. If we refer back to our diagram of how retrieval-based conversational AIs work at a high level, we can boil that down to we have one input off of which we make one prediction, to which we tie one output, hence one-to-one framework. This can work. In fact, if we have a narrow domain of knowledge or a very limited scope of use cases that can be interacted with through the conversational platform, and we keep things limited like that, and we make sure we have conversational guardrails such as buttons, which are pictured on this specific example, then chances are you can get away with having a good user experience with a one-to-one framework. However, if we go back and we think about when we talked about human-to-human conversation and how the brain has multiple regions acting as a network that are involved, and there are various feedback loops also involved in conversation, it seems to me like there's a rather large disconnect between this one-to-one framework and all of the areas and the type of network setup that the brain uses to engage in conversation. So that's why we're here today to propose a one-to-many intent recognition framework to ensure robust, scalable recognition of your conversational use cases. So what does that mean? We go back to having the same one utterance from our user, but instead of having one predictive output, we're going to look at several different categories that we could classify the utterance on, and we're going to make a prediction for each category. Then we're going to take all of those predictions and we're going to consolidate them into one final mapping that will be tied to a system response. That mapping we'll call a response mapping matrix, whereby the multiple classification categories fit like values in a matrix that are ultimately mapped back to a single system response. So how would that look like? If we're looking at it in a high level, essentially our response mapping matrix allows us to look at each utterance holistically from the perspective of each class, as each class will be classified through independent classifications, and each of these will be mapped together to map back to a response. So for example, let's say we had 4 different classes upon which we were to classify our utterance. Depending on the combination of labels in each class that we find, we're able to map back to a response that allows us to either disambiguate intelligently by asking for the specific information that is missing, or if we have enough information, validate in a natural format what we've understood before we proceed with executing a command. I'm a foodie, so of course my example is going to be based on food. But let's look at this from the perspective of ordering a sandwich. So if my sample utterance is, I want to order a sandwich, and my levels of classification are my intent classifier, my product classifier, my symptom classifier, and my aspect classifier, I can see that from each perspective here, I've picked up enough information to know what the basic intent is and what the related products are, but I'm missing a bit more if I want to give a specific concrete answer to my user, so I can disambiguate by asking for my missing classes. However, if, for example, I had said something to the effect of, I want to return my order because my pasta is gross, I would be able to know my intent of returning, my product, as well as my symptom, and I would be able to initiate an order return process. If we look at the system response as a process, what's happening is that based on the input of the user and the classes identified, we're able to either ask for one missing class, ask for multiple missing classes, accurately prioritize if we have multiple items from the same class, verify our mapped response if we have enough to concretely respond to our users, or at the very least, we can offer an appropriate alternative or an escalation point. And we talked about earlier how information architecture, or what the information that our conversational interface knows is related to each other is important. It comes into play here because even if we can't solve a user's problem, we're able to, in a very smooth way, offer related alternatives or appropriate escalation points so that users don't get frustrated even if we don't have the answer that they were looking for. I'll take you back to my times when I did user research with a lot of the folks that would be consuming one of the implementations that I was involved in. And I consistently got the feedback that feeling heard matters. When we implemented this one-to-many framework, users were thrilled. Because of the multi-level classification, we were able to very accurately use what felt like users' own words when we were verifying their request before executing on it, which led to reports of users feeling that our system was intelligent, our system was empathetic, and our system was able to reply to users using the user's own words, which overall led to a great user experience and reports of users feeling like they mattered. So we've talked a lot about the framework. Now let's talk about how we would implement such a framework. This is ultimately a data and design project powered by people. So there are lots of things we need to be mindful of. First of all, we need to figure out what conversational platform, what technological system we'll be using, because we need to work within the technical capabilities of that platform, and we need to design this framework within the technical capabilities of that platform. We also need to know what type of NLU or classification models we'll be using. We need to determine what our labels would be and what types of classification levels we're concerned with, as well as collecting and preparing all of the utterances that we will need to label within the classification model. From a people perspective, we're interested in a multidisciplinary team that can ensure representation of all of the different skills necessary and all of the different perspectives that different folks would bring to the table. To have success, it is important that from the outset of this journey, as an organization, we have defined use cases and analogous user journeys that are mapped to clear goals and a set timeline or roadmap for those goals, because making sure we have defined use cases allows us to incorporate the voice of the user from the outset to validate those use cases and make sure that we're solving the right problem. If you're following an agile type of methodology and using sprints, let's assume that you follow a typical 2-week sprint cycle. This is an ideal timeline of how you would engage with this type of framework building in the first 6 sprints. We have research at the outset and in the middle, because it is important, it is crucial to have the voice of the user through every step of the journey. We would spend a few sprints working on data collection and preparation. And in parallel, towards the end of that, we would be able to begin our design and development of our conversational use cases. And then finally, we would be able to start testing and validating those use cases. Now, a word of warning. A lot of companies see a conversational interface as an automation tool or a cost-saving tool, but it's very important to remember that an elegant conversation that engages users and helps them solve their problems in their language is what's going to keep them coming back to the platform. And that is going to be based on us being able to understand how the users speak, which in itself is rooted on having data on how our users speak, which can be a catch-22 for some. That's why, if at all possible, I highly encourage that the channel of your conversational interface be established before you add the conversational interface layer. That allows you to collect data in the same format as would be used in that channel. So if you would like to have a conversational interface via chat, chat as a channel would ideally be established before the conversational interface. And the same would apply to voice. If we want to have a voice-based conversational interface, voice as a channel should be established before adding the conversational layer, so that we don't run into that catch-22 scenario of not having any utterances from our real user base. Now let's take it back to scaling for conversational complexity. When we use scaling in the title of this discussion, how to design a scalable natural language interaction framework, in this context, we're talking about scaling for conversational complexity. Essentially, that means that over time, conversational complexity is bound to be introduced to your system, because you'll either need to support new types of requests, which will add linguistic variety, or you'll have a varied user base that will have varied linguistic nuances for essentially the same types of requests. So I argue that the one-to-one framework makes it a lot more difficult to scale for this conversational complexity when compared to the one-to-many framework for these reasons. With a one-to-one framework, you might have to create new intents. You will definitely have to retrain your models. There might be relabeling of utterances involved, and there will have to be a careful gauging and monitoring on how these new introductions impact the performance of your system. With a one-to-many framework, depending on the case, it can be as simple as editing an individual mapping for a specific response. Or if we have a brand new response we want to introduce, we could just add a new row with its corresponding mapping. We might not need to create new classification labels. There might not be any need to retrain our models or relabel any utterances, depending on the scale of change that is needed. So we save ourselves a lot of rework and make it easier to add new responses to map to by following this format. So how do we make sure post-implementation that we're on the right track? One of the facets that we will be very interested in tracking is response accuracy. So essentially, has our system accurately responded or inaccurately responded to the user's utterance? Has the user accepted the system's response or rejected the system's response? Based on these sets of parameters, we can take a look at what are true positives versus false positives versus false negatives, etc., what all of those are at a granular level. We would also be very much interested in tracking our users' behavior. There might be a plethora of different user behaviors that would be interesting to you depending on your specific use cases or scenario, but at a high level, for example, we would consider things like, was this conversation abandoned or was it completed? How often are the same responses being revisited by individual groups of users or by individuals or by groups of users? How long are our conversations with our interface lasting? What are the trends in terms of responses that users are accessing the most? Are users encountering errors with the system response, or are the system responses being executed accurately? All of these things are things we're interested in tracking, because when we tie it together, the accuracy of our system's responses and our users' behavior should give us the full picture of metrics that we will be interested in tracking long term. However, I think this is a very important thing to call out is that despite all of this, we should still be actively engaging with our user base, listening to their first-person experiences, combing through the transcripts of our conversations, and really investing in that level of quality. As Rachel Thomas from Fast.ai writes, all this data should still be combined with listening to first-person experiences. And this comes from a publication centered around how we can damage ourselves with the metrics in AI if we're not careful about making sure that they're in the right context, and even with the right context and the right data points, we make sure that the voice of real people is heard, because fundamentally conversational interfaces are made by humans for humans. So it is important for us as humans to hear each other. So we can conclude this by going over the framework for implementing this intent recognition framework. So we can conclude by going over the framework that we would follow to bring to life a one-to-many intent recognition framework within our environment. First, we need to make sure that our use cases and our goals are clearly defined. Then, we want to conduct user research from the outset. We want to think about methodologies like design thinking and how they emphasize quick Simple, cheap prototypes that really let us zero in on what's important to the user before we invest more in building our larger scale product. From there, we'll want to determine our buckets, aka our classification layers, and the corresponding labels within each classification layer, and we'll need to collect and prepare our users' utterances. We'll need to label our data, train our models, and develop the response matrix framework. We'll need to validate again with our users. We'll deploy to the conversational platform, and we'll monitor. And we'll incorporate this feedback to iteratively improve upon the performance of our system. And that concludes our discussion today. Thank you so much for tuning in, and I hope to hear from you.